Now, good morning, everyone. We'll just wait for everyone to clock in there as the participants log in as I'm watching the screen here. You're welcome to this morning's webinar. This is the 6th webinar we've had in the ERBA series. Today we're going to focus on domestic heating systems running on biomass, and we're going to look at the National Energy Plan that has been published in July in terms of how that will impact home heating over the coming decade and what the long-term plans on that are. So I'll just give a little brief intro to that, and we will look at what implications that will have. So I'm going to start off with two speakers today. We have Ger Cross from Woodco, who's going to speak on pellet installations for domestic houses, and we've Colin Byrne from Glass, who is going to speak on gasification systems, log boilers, for domestic heating. So I'll start off with that. First off, what I want to do is just, as I said, give you a rundown through the. Sorry, give me one moment. Right, you can see that. So the Irish Bioenergy Associations, as you would have seen in our presentations before, we're an organisation based in Ireland. We cover the whole island, and we cover fuels such as biomass, biogas, and biofuels. And we're basically running a number of workshops. We are we lobby on behalf of our members and advocate on behalf of our members, and generally promote the industry. First off, we just want to look at the National Energy and Climate Plan 2021 to 2030. Now, this is an ambitious plan launched by government in July of this year. A number of the measures we have seen before, and it's really putting them all together in one package, and it's good to see. What is relevant to us today is some of the plans that include the updating of 500,000 homes to a B2 rating under the BER measurement system, and that's to be done by 2030. They also call for 1/3 of commercial buildings to be brought to a B standard by 2030, and public sector buildings. They don't quantify the number. They just literally make the statement of public sector buildings to have a B BER rating by 2030. They also call for the installation of 600,000 heat pumps, and that there will be a ban on oil boiler installations by 2022 and gas boiler installations and new connections by 2025. So it's quite an ambitious plan. It is at the level that we need to reach the decarbonisation level that are required under our commitments and in general facing the climate crisis that's ongoing. So it is an ambitious plan, but it is also in line with meeting those targets. So the ambitions that are there, the overall figure of the reduction of carbon emissions are relevant in terms of, just to break down some elements of it, the 500,000 retrofits of existing homes by 2030. Again, it's quite ambitious. We're looking at 55,000 retrofits each year starting in 2021. That is directly competing with the building sector, and there's quite an issue with that, because the labour market at the moment in the building sector is very, very tight. We are struggling to meet the target of building 30,000 houses per year, whereas in essence we are looking at a housing shortage in the country. So we're looking at needing far more than 30,000 to be completed. So it does, by looking at deep retrofit, which that 55,000 units per year, that requirement, it does require a significant work on houses. It does require significant building work to re-insulate, to re-envelope those houses, and to put in the measures that are there. So there's quite a crunch in terms of requirements on labour, and that is one factor that hasn't really been addressed at this point in time, but it is one that is going to very seriously impact meeting those targets. And the other significant factor is the homeowner decision process. Each homeowner, the 55,000 people will need, 55,000 houses will have to make the decision to make a deep retrofit, which involves significant reconstruction of the home, significant upheaval for normal day-to-day living. So it does require and significant investment. So from that point of view, it is going to be quite tough to get that level of retrofits completed per year. And look, we absolutely do like the target, and do consider it worthwhile to have that level of target. But in practice, it is going to be extremely difficult to achieve. The estimated cost ranges for standard houses is between 40 to 60,000. for each of those retrofits. So it's a significant investment, and that's based on relatively small or the average size house to below average size house. So it's that cost is significant, and we have to bear in mind that those sort of costs have to be borne by the homeowner and also by the state if there's going to be significant grant aid. At the moment, the grant aid runs at it works out at around 35%. The decarbonising options for houses, and we have a large housing stock. That 500,000 figure was put in there for a reason. We have a very difficult task, in particular in rural housing that are not connected to the gas grid, in how we're going to look at converting all those houses over from oil and converting over from other products such as peat. There is a significant number of those houses around the country. They're generally a little bit larger in size and also would have higher energy requirements than the average. And there is some advantages and disadvantages in the way they're laid out, but it is significant in terms of meeting and decarbonising those houses. So predominantly we're looking at that area at the moment. The two main methods for decarbonising those houses is, the first is to look at the energy rating improvement, which is the deep retrofit, and adding in heat pumps. Now, the homes must be upgraded, deep retrofit, which I've discussed already. There is a high capital cost to doing so, as I pointed out, between 40 to 60,000, and much further north of that for larger houses. But there is the payback on that is it's a low running cost. It does reduce the heating cost significantly in the long run. So that is there to help to pay off the capital. The carbon emissions are reduced dramatically, and it does move towards the electrification of heat. So that's one option, which is that deep retrofit and installing of heat pumps, which is one method of decarbonising houses. What we're going to look at today with our two speakers is the biomass replacing fossil fuels. So we'll discuss some of the technical options with our speakers later on. But really what we're looking at is directly replacing oil and solid fuels. So you take out your oil boiler, normally a unit sitting outside the house or local close to the house, and replacing that with a solid fuel system, with a pellet system, with a log fuel system. The conversion is very simple. It doesn't require any works within the house itself, or very little works within the house. And it can be literally done outside and done relatively quickly. A team can easily manage that changeover over the course of several hours to a day. So within that, the heat demand, obviously, because you're not changing the envelope of the house, the heat demand will remain the same. There is a low capital cost involved in this, and there is comparable running cost to oil. So it is a little bit, there is savings to oil in terms of in the order of about 20 to 30%, depending on what you're replacing. And there is then, the other major advantage is you have got significant carbon emission reduction from carrying that out. So this is just a quick table I'll show you. It's some of the main work we've been working on this to try and model what is going on. So if you can break it down into your existing scenario, so the do nothing scenario, if you consider your house, this is based on a 150 square meter house or 1500 square foot house. So using an existing oil boiler, an old style oil boiler with efficiency of about 65%, the annual heat demand there will be about 24,000 kilowatt hours. The annual CO2 emissions, as you can see, are almost 10 tons for heating. And the annual cost of heating runs at around €2,500 per year. So that's what we're starting off with. That's the house we're starting out with. And again, the two options we're looking at here is one, converting over to the oil boiler to a biomass boiler, or the other is a deep retrofit to the BER rating of B2 and installing a heat pump. So with the biomass boiler, as I said, your heat demand remains the same at 24,000 kilowatt hours. Your annual CO2 emissions, as you can see, are reduced down by 90% from 9.58 down to 0.95. So there is a significant reduction in CO2 emissions. Now that can be reduced further as we further refine the process for producing pellets and logs. And indeed for logs would be lower than that, is based on pellets. The capital cost for simplified systems is running at around 6,000. We've seen different figures going from that to plus and minus 20 to 30% on that figure. That's just a figure we've pulled in there. And the annual cost of heat, as you can see, is reduced by about €600 per year. So there is significant reduction in the cost of heat. Now, we have run that figure out over 25 years, and I'll look at this more in a comparison. Maybe I'll just go to describe the heat pump first, and we'll look at the comparison then. Sorry. With a heat pump system, you're first of all retrofitting the house. So bring it down to a B2. Starting off, the initial thing here we looked at was a C2 house going down to a B2. Sorry, a C3 house going down to a B2. And you're reducing the heat demand, as you can see, significantly from 24,000 down to 10,000. Your CO2 emissions are reduced down to 0.7 tons. So again, significantly reducing the initial impact of 10 tons per year. The capital cost is quite high, or is very high to win a deep retrofit house at 65,000 euros for that in capital investment. As I said, the current grant rate on that runs at around 35% from what we understand. There's different methods by how it's calculated, but the anecdotal evidence is it's in around 35%. The annual heating cost, as you can see, receives a dramatic reduction down to 400 euros per year, and that would be through your electricity. So it does have a significant change in the running costs of the building. The total cost then, so just to give the comparison then between the two, what we've looked at is, we ran it out over 25 years. We looked at, many people look at investment, you would look at over 10 years, 15 years. We ran it out at an extended period of time to give it, first of all, because to spread the cost of the heat pump system and the retrofit over as many years as possible. And we looked at how that would impact the overall figures. So the total cost, when you take in the savings in fuel costs, to take away from the initial capital cost for a biomass system, is you get savings over the 25 years of 6,000 euros. With the heat pump system, you still have another 9,000 euros to that expenditure after 25 years. You're still laid out by about 9,000 euros. If we add an interest rate into that to go with present values, and 5% is the standard figure used by government bodies, you can see here that the biomass system would have saved over a period of time about 1,000 euros. Based on today's money, really what present value is exactly what it says. It brings back to present values. So you can take it that the decision would save you about 1,000 euros in today's money. And in terms of the heat pump, it is going to cost 33,000 euros. So there is, and that's largely because you've such an upfront cost at 65,000. So it's very significant. We've then broken that down into the cost of greenhouse gas abatement over the 25 years, based on the savings, as you can see, of approximately 9 tons for each technology. And what we've got there is the cost per ton of greenhouse gas abated is minus €5 for biomass boilers. So effectively, you're saving money as well as saving carbon over that period of time. And then for the deep retrofit and the heat pump scenario, it's costing €152 per ton of carbon. So it's quite significant in cost. The models are there in the background. If anyone wants to have a look at those, we're more than happy to discuss that with them and run through the different scenarios, because it can change depending on some of the figures you put in there. But in general, you will see that level of disparity between the two. So if you bring that into context, the current carbon tax is 26 euros per ton. The current trading price of carbon is around 26 to 28 euros a ton. And government bodies are looking at moving the carbon tax to 80 euros a ton by 2030. So you can see there the cost of the heat pumps wouldn't offset the carbon tax that's going to come in. So it's quite, it's one of the more expensive ways of doing so. Then we've looked at a rollout of over 100,000 houses, just to look at the national figure, and you can obviously multiply that out. The capital expenditure on this scenario for 100,000 houses is 6.5 billion, so it is very significant. It's about 10% of that cost, or less than 10% for the biomass boiler system. And then the CO2 savings over those years, the 25 years, as you can see, is in around the same, slightly higher for the heat pump system, at about 22,000 tons per year, or 22 million tons per year. Bring that into comparison, or sorry, that 22 million tons over the 25 years, we in Ireland are emitting 35 million tons per year. So it just gives you a bit of comparison, 22 million tons over a program such as that compared to the national figure. Lastly, before I pass over to Ger, I just want to give you a quick rundown on some of the information. One of the questions that often comes up in biomass is emissions of particulates. So we have taken the figures from the European guidebook on this. So you can take a look at open fires, old stoves. Sorry, I'm just looking at the cursor up here. Your efficient stoves, your eco-design stoves, and your pellet. So as you can see, there's a dramatic reduction when you move from even old stoves at 40 kilograms. This is based on if you use that heating source for the entire heating for a house for 1 year, the average house in Ireland, which is 15,000 kilowatt hours. So you'd move from 40 kilograms of particulates per year down to 1.6 for a pellet stove. Now, that would be obviously the very same for a pellet boiler system, or a log gasifier would be somewhere in around that level. As you can see, obviously gas and kerosene are less than that, and zero for gas. And taking it that electricity, we don't have figures for what the electricity grid is producing in terms of particulates, so we've left that at zero. In terms of CO2 reduction, the greenhouse gas emission reduction for that standard house, currently if that house is running on kerosene, you have 4 tons. Again, it's a lesser figure here. We ran that based on the most efficient gas boiler out there. It would run at 4 tons per year. If you go to gas, it would run at 3 tons. All of your wood fuels, as you can see, bring it down here to, in a matter of a couple of 100 kilograms of CO2 per year. And then the heat pumps, depending on the electricity on the day, the lowest we see in the grid is 200 grams per kilowatt hour. So, and we would look at that figure as where we'd hope to get by 2030 with our electricity grid. You're looking at about 1 ton of emissions per year. Now that house is based on no retrofit, obviously. It's just looking at the overall production of 15,000 kilowatt hours per year. So after that, we'll have information in the slides when it goes out if anyone is interested in becoming a member of Verbia. So you can have a look at that, and you can see we've lots of information on our website. But from that, I just want to pass you, the next person I'd like to bring in is Ger Cross. So Ger runs Woodco. He's the commercial director for Woodco, and they manufacture wood pellet boilers in Tipperary, and they're also involved in installation. So they do both industrial and domestic systems, and Ger is just going to give a run through of what they offer and what is available out there in the domestic scene. So Ger, if I can pass over to you, if that's okay.
Yeah, thank you, Noel. Good morning, everyone, and yeah, I'm happy to be invited this morning. So it's yeah, I've been working in the pellet industry in Ireland for over 10 years, and I've seen a lot of changes in it. So one of the things I just wanted to do, which is this morning, was just share with you just a bit of a journey of pellet heating in this country. So I'll just pull it up if you can see it and share the screen. Just a second now. Okay, can you see that?
Yeah, Ger, we can see that. That's okay.
Yeah, I'll just go up to the top now. Okay. Okay, so really what I've just said, just 15 slides. It'll be probably 10 or so minutes. And it's wood pellet appliances and applications for them in Ireland, and how we're seeing things changing over the years and a greater adoption of them. So I suppose our journey started out, and this isn't about Woodco in any means, it's just a little bit of the journey of wood pellets in Ireland, but our journey particularly started out with social housing. We got, which is something you wouldn't ordinarily consider wood pellet heating in. We were approached by the housing executive in Northern Ireland over 10 years ago to come up to design a wood pellet fired boiler that could be used in social housing properties. And it was a bit of a challenge, but really their motivations for doing it, and this is the interesting part, one was fuel poverty. They had a huge issue with fuel poverty in some of the housing estates in Northern Ireland, where oil was the predominant fuel, oil or electric, and very expensive forms of heating. Secondly, actually, allied to fuel poverty, their tenants were having to go down when oil hit 70 or 80 cents a litre. They were having to go down to the local filling station and fill a 5-gallon drum of oil and bring it to their house. And invariably, oil got spilled in the back gardens and so on, wherever their boilers were, and that led to investigations into oil spillages and environmental impacts. So they had to, 1 year alone, the housing executive in Northern Ireland spent £1 million on investigating oil spillages in back gardens of properties. So that was another motivation to move to pellet. And obviously a third motivation was a lot of the houses were terraced houses along in a row, and the oil lorry used to pull up at the front and pull the oil line in through the front door, out the back door of the house to the oil boiler, to the oil tank at the back. And again, this was deemed illegal and for insurance reasons. So we developed a little pellet boiler and we had resounding success with it. They're the types of properties they were typically sold. Again, a property you probably wouldn't ordinarily consider putting a pellet boiler into. So we had a good lot of success in Britain then. Local housing authorities and social housing bodies embraced it. Like there's a picture going back to one of the first boilers about 10 years ago in County Armagh. The client is putting his bags of pellets into, holds 110 kgs, lasted about a week and a half. And again, it was a solution to fuel poverty. So it proved very well. There's a number of the local authorities or the councils we worked with throughout Britain and Ireland. And I suppose it was an outdoor wood pellet boiler, which is a little bit unique to this part of the world. And we've all become accustomed to an outdoor oil-fired boiler. So we just designed an outdoor pellet boiler. And just in more recent times then, that's just one we did in Port Tarleton and County Offaly this year. Again, it's quite, if you didn't know, you'd probably think it's an outdoor oil boiler. That's an outdoor pellet boiler, holds 110 kgs of fuel, and the tenant or the homeowner in this case fills it every week. And in that case, they displaced a solid fuel turf burning range, which was inside in their dwelling. That boiler was fitted within 1 day. So that's, it's fully weatherproofed and it sits outside. People are more familiar, I guess, in Europe with putting their boilers in basements or in garages, and also we have an internal range of boilers, and that's quite typical. You see a happy customer there on the left from County Kilkenny. You can also see on the picture on the left just the auger. He has an outside fuel bin, 3.5 tons, and it's automatically fed into the boiler. You have automated cleaning, automated deashing in many cases, PID control, fully modulate from 100% down to 30%, very efficient, over 90% efficient in all cases. The boiler on the right, a boiler in Athlone in the middle of Ireland. Again, the client in this case didn't want to purchase a 3-ton silo, so we have a separate bin which sits beside it, which holds 400 kgs of fuel. And it's all automatically fed. So at any one time, the client probably has a half a ton of pellets in his fuel store. And he can see there, he has a bag of pellets, he fills it manually. Again, in Europe, where we've supplied boilers, you see them in the basements. And this is a typical, one of our slim boilers in a basement. In Ireland, most people don't have basements in their properties. So they either put them outdoors or in a garage away from the property. But that's a typical, that picture would be a typical installation in a basement. Nice and tidy, of course. And as I said, most of, if not all of the boilers are now Wi-Fi enabled, and you can control them from your mobile phone and all of that. I mean, some of the criticism of biomass boilers and pellet boilers in general, even when the RHI, the Renewable Heat Scheme, was running in Britain, was it was considered the preserve of rich people. That basically, the RHI was most people, the most people that benefited the most from it were people that had large properties and could afford to spend 15, 20 or 30,000 euro on a heating system. And certainly, I suppose the slides I've shown you up to now have shown that you can do it on a low cost, and pellets should be the preserve of many other people rather than rich people. But having said that, we've done some nice properties, large properties throughout Ireland, and we do an eco cabin version, which is a plug and play solution where the boiler, fuel store, the entire plant room is in a containerized solution and dropped on site. This particular one was on a listed building in Cork City. We supplied this year, and it displaced 14,000 litres of gas with wood pellets. Again, another property here, again, the same idea, a 5-bed property in rural West Cork. And you can see the 2 pipes on the right hand side, that's where the pellets are filled in. There's a 5 or 6 ton fuel store inside in the eco cabin. The picture on the left, you can see the fuel store, the auger, and the boiler, and a buffer tank. So it's a nice installation. Just so pellets are they do make a lot of financial sense, where particularly on large properties where there's big big energy demands of 20, 30, 40,000 kilowatt hours a year, then a pellet boiler is a great solution to decarbonising and to saving money. So some other new appliances that are coming to the market, we're trying to bring wood pellets mainstream, I guess, and you know, boilers is one side of it. This is a nice product. It's a wood pellet cooker. It's 14 kilowatt. There's a picture of one installed in a home in County Tipperary. You can see it's a nice natural flame. You see the flame effect, so it gives the effect of a stove in the living area. Also, it has a boiler, 14 kilowatt boiler. So this particular cooker does the central heating as well. And also it's an oven. On the right, you can see the oven where they can cook. And it also gives nice ambient 4 kilowatt of heat out to the area, the kitchen area itself. You can boil a kettle on the hot plate. We do have bolster covers as well, which you can pull down and put on top of the hot plates. So again, I see this as a very interesting product for the Irish market. In the Midlands in particular, where lots of Waterford Super Stanley cookers would have been sold over the years, over decades, where people bring in turf, fill their boiler, manually light it every day, manually take away the ash every day, and heat their homes relatively cheaply, but not very good for the environment, I'd have to say. Now they can go to a wood pellet cooker, fill it with a bag of pellets, remove the ash pan once every 2 or 3 weeks. Very efficient, very clean, and it's an exciting product. Pellet stoves, again, pellet stoves have been tremendously successful and popular, easy to install, and Italy is a very good country. There's something like 60, 70, 80,000 pellet stoves a year installed in Italy, and I have to say in Ireland, it's very heartening to meet lots of people who have put in pellet stoves, have a very good feel about them, very good news story, and we should be leveraging that success to promote all sorts of pellet heating. They're getting more and more popular and people are getting used to it. This is another pellet stove from Cadell in Italy. We work with them, and again, this is a boiler, so if somebody wants a nice natural flame in their living area, and they can also centrally heat their boiler, heat their home, it's manually fed and fully automated, all the usual stuff, automatic cleaning, Wi-Fi enabled, and very stylish and a nice feature in the home, so that they're becoming more popular in Ireland.
Jaron, just give me a minute there at that point. Thank you.
Yeah, there's 2 more slides, I think. Thanks, Noel. And so just to finish then on just pellets becoming more mainstream, I mean, there's pellet patio heaters. That's a nice celebrity chef up in County Cavan. Neville Maguire has put in 2 pellet patio heaters there. And okay, he doesn't have a pellet boiler, he doesn't have pellet heating, but at least it's a first step, and you know, another good feel-good factor about wood pellets. Another one in a property in Kinsale, pellet patio heater for outdoor dining, which is becoming more popular in this country because of the COVID. And finally, then there's pellet barbecues. So, you know, people can enjoy pellets, lifestyle choice. It's outdoor. You can cook on your wood pellets, and maybe that's the starting point for some people to use pellets. They buy a wood pellet barbecue first, and when they get used to buying the pellets and get comfortable with the whole idea and concept, they can move to a wood pellet boiler or a wood pellet stove. Okay, that's my presentation concluded, Noel.
Okay. Sorry, Ger, thank you very much. That was excellent to see, and the range of equipment that's available is definitely very interesting. We'll have a few questions later on, and if anyone has questions, just to let you know, at the bottom of your screen you should see a Q&A tab. So, well, it's on the bottom of my screen. It could be it's different for yourself, but if you want to put any questions there in writing to us, and we'll be able to address them then at the end. As well as I noticed a few people have had some technical difficulties. We've just got a few messages in. There's been some technical difficulties. Our apologies for that. We're trying to sort those. I think they are sorted at this stage, but again, if you do have any more issues, let us know. And again, our apologies for that. So I'll pass over to Colin Byrne. Colin is, I don't know how many years you're at this, Colin, but you're at it longer than me anyway, I know that much. Colin is installing boilers and from district heating to single systems for many years. And I've asked him today if he'd give us a talk on gasification and log stoves, log boilers for domestic heating, and he's well capable of speaking of a lot more as well. So I'll pass it over to you there, Colin. Thank you.
Thank you, Noel. As I say, for more years than I care to remember. I first got involved in renewables, in particular in 2002 when I set up Gloss, and the first pellet system I installed was about 2004, 2005, so it was one of the first in Ireland, and I have all the scars to prove it. But this morning's talk, and thanks again for the opportunity, I suppose, to present, my talk is specifically around wood gasification and some options around using solid fuel for heating homes. And I'm going to take you through a few slides here that I suppose gives an overview of what's required, I suppose, to just, I suppose, firstly to set some expectations on the quantities of timber, the energy content, some of the technologies that's available, and I suppose what's required from a plumbing and installation perspective. And then I likewise show some examples here as well, just to put it into context. I try to always start any talk about timber on a slide about moisture content, because it's critical in terms of solid fuel that we get this, I suppose, culture of using properly seasoned timber embedded into rural Ireland. It's something that you see in a lot of the Eastern European countries, and particularly in I suppose the areas around Bavaria, where I first started to work with some of the biomass boiler technologies. There's a long tradition there, I suppose, of harvesting a year or two ahead in preparation for your heating season and allowing timber to naturally dry. And it obviously is the lowest carbon method of drying the timber, to just let nature do it rather than be consuming fuels to dry timber. The graph here, I suppose, just gives you an indication of the energy content versus the weight of the timber. And I suppose there's that usual story where in Ireland, typically, if there's 2 fertilizer bags full of timber outside a garage, typically you pick up the heaviest one and think that you've got more fuel, but you've actually just got more water. The graph here will show you, I suppose, freshly cut timber, which is typically around 50 to 55% moisture, has only about 2 units of energy. Oh, sorry, let's get back to that slide. Has only got about 2 units of energy for every kilogram of timber, whereas we leave it to even season for one summer and get the moisture down to about 30%, the energy content goes up to about 3.5 units per kilogram. And then properly seasoned timber, we can, down to 20% moisture, we can start to hit 4 units of energy per kilogram. You'll see pellets there on the graph as well, which typically around 10% moisture is the highest energy content per kilogram, which gives us that energy density we're in a compact fuel. So again, it's just reiterating the importance of seasoning the timber prior to combustion. So a kilogram of good dry timber gives us about 4 units of energy. And to put that into context, if we look at a litre of oil provides us with roughly about 10 kilowatt hours of heat, and which again is equivalent to about 2.5 kilos of timber. So often when people are trying to quantify how much timber they'll need to heat their home, we compare it to 1,000 litres of oil. So 1,000 litres of oil will require 5 to 6 cubic meters of hardwood, of oak or beech, which has a higher energy density, and softwood, then we need about 7 to 8 cubic meters. You'll see a photograph there on the left of what a cubic meter looks like. So just to put it into context, if you're burning 1,000 litres of oil, you need somewhere in the region of 6 to 7 of those palletfuls of timber per annum to displace that oil. I suppose based on that, we can calculate what an annual timber consumption requirement is for a home once we have a historical reference on it. Very briefly, I'm just going to talk about probably the oldest method of gasification that is still in action today. It's a system called a cackle oven. It's not something I'm going to spend too much time on, but just to very briefly describe it. When you gasify timber, when you get timber up to a proper temperature above 150 or 170 degrees, it starts to release the gas in the timber, and it's that gas that you want to capture the energy from. And capturing that gas in a controlled environment and then storing that heat is something that's been done for hundreds of years. Actually, the oldest cackle oven system is about 500 years old in a large cathedral in Salisbury, and it's actually still used today. And basically the concept is in a controlled environment, you light a fire, give it full oxygen at the early stages of combustion to get the temperature up within the fire to about 800 degrees, but within the core of the fireplace. So these are specifically designed ceramic core fireplaces that are built for this purpose. The core itself starts to increase in temperature and rises to about 600 or 700 degrees and basically radiates that heat for 24 hours. So you light a fire once a day, and then you've got 24-hour radiant heat from this system. They're obviously not for everybody. It's just a technology I do want to flag. There's a couple of companies doing them in Ireland. It's not something I do myself, but we put one into our office back in 2003 in an old mill, and it's actually a pleasure to be around. Here's just a couple of examples of the kind of scale that they can come to. You can start with a small type unit, as you see in the corner in the sitting room. And this probably more comes into play for both new builds that are very low energy house designs that don't necessarily need an underfloor heating system or radiator system. Something like this could provide the whole heat for the house. You see the one on the right there, which is actually a castle in Tipperary. So you can go to any scale with these and any design. So it's just something I wanted to flag. Starting off as and no plumbing, no maintenance, clean out the ash once a year. Lot of advantage to it, and very clean burning. When it comes to gasification boilers, this is where we're basically trying to as efficiently and conveniently as possible use timber to meet a daily demand. The boilers I started to work with back in 2005 are designed by a Bavarian company that have a tradition, I suppose, in log heating. So the company started off building these boilers, but the idea here is to have a fueling chamber that has the heat capacity to meet the daily demand of the house. So in other words, to minimize the labor interaction, you fill the boiler once a day with enough timber to meet the daily demand where possible. So that's typically where, and obviously that varies dramatically based on the weather, based on usage in the house, etc., etc. But the general principle is that we try and size the system so the fill of the timber in the fueling chamber that you see here meets the daily demand. This is a typical boiler that we install with it for about 20 to 30 kilowatts. It holds about 150 liters of timber. The gasification process basically it requires you to have control of, sorry, go back up a slide, of both primary and secondary air. So you're feeding air into the first combustion chamber to get the temperatures up, and then as it releases gases, you're feeding air into a secondary chamber. Basically the function being to extract the maximum energy from the timber, and these typically run at between 90 and 93% efficiency. Very clean burning. It does require that manual interaction on a daily basis in the winter months, but obviously as you come out of winter, you could potentially fill this once a week in the summer months to provide all your hot water. There's various different shapes and sizes. This is a different type of model, which is a top loading, has a higher output, has also got an optional liner inside the chamber that allows you to put sawdust or shavings in if you're, particularly if you have access to fuel in a timber workshop, for example. And this is probably one of the largest we do, which will take a 1 meter long log. Again, it's a front loading and has a top loading option. So these come in various shapes and sizes, but the whole concept behind it is convenient heating with solid timber. Again, it does require essential that you have your timber dry down to a low moisture content in order to get that gasification process working smoothly. It also ensures that you have a very clean burn. You shouldn't really see any smoke after the first minute or two when it lights up. It should be just like hot air coming from the chimney, and proper combustion means no tar and very, very little ash. So and that is driven primarily by having properly seasoned timber and obviously good control systems on the boiler. So in terms of what you typically need in the house, we always install a buffer tank system with our log boilers. The buffer serves basically as the means to store the energy that the boiler is producing. So you fill your boiler once a day, let's say it's first thing in the morning. Your heat demand is spread out over 12 to 18 hours, but your boiler combusts at full efficiency for 5 or 6 hours, and all of the heat contained within that timber, or 90% of it, is stored in the buffer tank to be available on demand in the house. So what you're seeing here in this basic schematic here is your hot water cylinder within the house, your heating circuits, which can be on a thermostat time control. Your buffer tank then is heated by your log boiler, and on-demand water from the buffer tank is circulated through your heating circuits and into the hot water in the house. So that's your basic configuration. The size of this buffer is directly proportional to the energy content that the boiler can produce from one burn. So the fueling chamber size determines the size of the buffer tank, and it's an essential component for providing that cushion and ensuring that the boiler runs at its optimal efficiency. If without the buffer here, once the radiators heat up on the system and the water starts coming back warm to the boiler will automatically have to start shutting back its combustion, which then means it's smoldering and not combusting properly. So buffer is essential for clean burning. This is just a similar schematic where in some cases we leave the existing oil boiler in place. Obviously with timber, it means you must fill it on a daily basis if you want heat. Some people like the convenience of being able to switch back to oil or have it there as a backup. And again, it's quite easy to integrate your existing oil boiler into a system which gives you a kind of I suppose, a dual fuel option. And more often than not, we find that when we integrate it, we go back in a year or two and the customer hasn't used the oil boiler at all, and they're in the process of taking it out or have taken it out. But it's there as a backup cushion, I suppose, for those that are concerned about the transition, should I say. Like Gerard's technology there, the control systems on biomass systems now are quite advanced, touchscreen, remote access. You can control all the heating circuits in your house. There is even an automatic ignition version of one of the boilers, which allows you to fill the boiler in advance and then control it remotely to light it from a remote location. You can obviously, as you see here, integrate other heat sources like solar into the mix as well, and can be controlled from central smart control. These are just a few examples. I suppose what we see is a lot of this where many farmers and rural dwellers have access to some timber. This is a typical farmhouse in rural Kilkenny, stone building, nigh on impossible to insulate internally, and definitely not going to do an external wrap insulation here. Have done the windows, have insulated the attic, but yet it is still a D rating, and this person has access to timber. And one of many customers that is extremely frustrated about switching to biomass and not being eligible for a grant to reduce his carbon emissions and switch to renewables. So it's definitely something I want to flag here, that it needs to be considered to be brought back into the SEAI Domestic Energy Upgrade Grant System, because I sense huge frustration from potential customers that it's not being supported. This man has all his own timber. He's actually been collecting timber for 2 or 3 years, waiting for his time to install his log boiler, and frustrated at the fact that there's no grant available. So went ahead and did it anyway this Christmas. People often ask me, how much timber does it need? And this man will tell you exactly what he uses. About a wheelbarrow a day, Colin. That's exactly what he does to heat his house. So it's not a scientific measurement, but you can see it on the right there, that typically a house like this will use about a wheelbarrow of timber a day. We've done all sorts of shapes and sizes. This is a much bigger house here.
Thank you. 2 minutes
Period.
for Colin if you can.
Okay, it's a period building with some outbuildings that are also converted.
Sorry, Colin, you're gone on mute there for some reason, and the screen is not sharing. Can you hear me?
I don't know what happened.
It's mute. You can back there a second, and you're back on mute. There you go. Okay.
Yeah, is the screen still sharing? Sorry.
No, it's not. Sorry, it's not.
Okay, something happened there. The share screen. Okay, we're back.
Yep, perfect. Thank you.
Okay, sorry. So very quickly, yeah, this is an unusual one. One boiler is providing heating for effectively 2 homes here, the outbuildings. So the father-in-law fills it in the morning, heats the main house, and then the son-in-law comes home, fills it in the evening to heat the second house. So that gets a lot of work, but is capable of heating 2 buildings. No, sorry first. This again is another large country house. This is another example of the challenges. This is not viable to put a heat pump in this house. This is one in Laois here, heated with a 30 kilowatt boiler and a 2,000 litre buffer. Interestingly, HDG have also developed a combi boiler, which takes log and pellet, which gives that automation plus the potential to use your own timber. So very briefly, why I would see wood as an essential part of the energy mix. Obviously, we know from your slides, Noel, that it's a carbon neutral resource. This obviously is a big benefit with the talks of carbon taxes from a homeowner's perspective. You're secured from that. So it gives this long-term price stability, especially if you have the location to grow your own timber. It's now very proven technology. It's very convenient to use and it's very clean. I suppose it's a sustainable indigenous resource and it has huge benefits for not just the user but also the local economy. And I see huge potential. I'm doing work with some rural communities, and we're looking at energy plans for the 5 to 10 years ahead. And we see biomass as an essential component for benefiting the farming community. Like one town in particular in Kilkenny, 2,500 people, there's over 2 million spent on heating that leaves that town every year. At least half of that could go to the local farmers or to a wood fuel resource in the town. So it has a massive impact, not just on carbon and on the homeowner, but also on the rural economy. So it's essential that this gets the attention that it deserves. Again, you've hit that one, Noel. It doesn't need massive investment in insulation and energy efficiency to work. I would still emphasize that you should, where feasible, reduce your demand, because the unit of energy saved is the most valuable one. It means you're not burning unnecessary timber going forward. That's a little bit about ourselves. There's anybody that wants to know more, I'm sure Noel's going to share the slides. So that's my lot. Thank you very much.
Tom, thanks very much for that. It's definitely been it's very interesting again to see the full range of equipment available there. We've quite a number of questions, which we'll try and get through. So what I'm going to see if, first of all, Ger, if we come back off mute there, we'll get you up on screen. So we'll run through these questions. There's quite a number of them here. Now, first off, start out very simple one for you. First off there, Ger, to yourself, how much is the kitchen cooker? So if you want to, I can pass on the contact for that if you want. So that's yeah. So interestingly enough, I have quite a number of questions. I was going down through them there when Colin was talking. There's quite a few people inquiring those sort of questions coming in.
Yeah. The next one then, just to answer it, you know, it's comparable with a solid fuel cooker, so it's got all the advantages. So you know, it's not overly expensive. Yeah.
Right. Okay. Perfect. That's and again, that'll be available on your website. You can find out there for that anyway. So, so the pellet heating systems use chipped wood. Do you want? I don't know. Any of us could answer that, or Colin, do you want to take that one? Or
I'm happy to that. I'll be a Ger, I suppose, the talk on pellets. But, primarily, pellet boilers are designed specifically for feeding a very refined fuel in terms of the size of the pellet, the dust content, etc. There are some boilers that would take both fuels, but automatically feeding wood chip to an automated boiler requires much more robust augering systems. It's much more difficult to handle, and you typically choose one or the other. But the larger systems are definitely able to take pellet and chip. The smaller systems are typically pellet only. But maybe Ger might have something to add to that.
Yeah, no, that's exactly right, Colin. I suppose chip is bulkier material as well, and generally domestic properties don't have space to accommodate bulkier wood fuels. So yeah, that's so pellets for that.
Yeah, possibly something more for when you're looking at a house maybe greater than 3,000 square feet, or the older type.
Yeah.
Estate house, something like that. It definitely, we see a lot of options in that. All right, but
I might just
storage of pellets is more convenient.
Yeah. On some of the log boilers that we do, some people mix in chip with the log. One of the boilers I showed there has a kind of a liner that will allow you to fill it with chip and still have the air circulating through it. But a lot of people will throw in their chip and their sawdust from processing the timber in with the timber, but they're not specifically chip boilers.
Okay, and we would see a lot of the firewood producers as well will put all their offcuts into a log boiler like that, either for their own home heating or for drying, for running a kiln. Now, again, another question there. Somebody, anonymous attendee, looking for the cost of the eco cabin for a 40 to 70 kilowatt production. Again, that's something that you can contact the suppliers directly for that. Obviously, there's a lot of systems taken into account on that, but that's something that I'm sure you can take up directly. Is there a grant aid for biomass boilers heating of homes? And also, I see George shaking his head, and there's not at the moment. A question over, is there a potential for prices to increase if there is a grant put in place?
Well, first of all, yeah, there's no grant, and that's a much to our dismay. There's no grant for biomass boilers in domestic, and it's something we really need to lobby for in Ireland now, because there's a €3,500 grant for a heat pump, and there's no grant for a biomass boiler. And as your slides showed earlier, Noel, biomass boilers have a huge part to play in decarbonising heating in Ireland, so it should be encouraged. And the second part of your question, Noel, forgive me.
It's mainly, well, I think it relates to, we often see...
will prices increase?
Yeah, basically in meeting the requirements of the grant aid, I suppose, is what often happens there.
Well, to be fair, I suppose both Colin and ourselves, I suppose we do install the boilers as per best practice, buffer tanks, controls and all of that. So I wouldn't see, unless there's red tape associated with doing grant applications and stuff like that. But from an installation point of view, I wouldn't see any changes in price.
Yeah. It's probably a good time to just point out as well that we have a register of certified installers here in the country, of installers and designers. Both Colin and Ger are on that. We have really, what we're trying to do as an association is we are looking to, in the next couple of years, move it to a statutory footing, similar to where you need a registered gas installer, because you need an expert that knows what they're doing. In gas, mainly for safety, in biomass, mainly to ensure that the system is properly installed and it's done by somebody who's properly trained and competent to do so. So it is possible to go out and find people that will install a biomass boiler and don't know how to do it, and you will find that those costs may be cheaper. So we would ask anyone that's looking at this to, on our website, you will see the register of those that are certified installers. And it's a reputable list, and it's something that we would advise anyone to go to and have a look at first. The next question then, in terms of particulates, even though the particulates are a lot lower in wood pellets and log gasification boilers, is it still an issue? I'll just take that one in that we've just completed a study on air emissions, mainly for industrial, to look at what impact it may have. And the tank, when we look at the results of that, and it's done by an independent body, it's currently been sent to the EPA for them to look over, and the impact it has on local air is not an issue. What's also interesting, the International Energy Agency brought out a report earlier this year, and when we looked into it in terms of particulates, you will see a dramatic reduction in particulates by putting in proper equipment, and also the fuel quality is vital. So the Wood Fuel Quality Assurance Scheme here in Ireland to certify wood fuels, and as Colin was pointing out, the moisture content is critical in that. And what you find is higher moisture material will produce more particulates if it's burnt in the wrong appliance, or in an appliance not designed to burn higher moisture material. Now, no homeowner should be looking at high moisture material. The only time you see that as a practical option is large industrial systems. When you have the particulates coming out, and it's a much smaller amount coming out of a wood pellet and the gasification boiler systems, it's a much different material coming out. It's no longer an unburnt fuel. What is problematic in particulates is these unburnt particles. Generally, when you get to when it's burnt right down, what's left is very inert material coming out, which first of all is very dense, so it settles very quickly out of the air. But as well as that, it is not associated, and this is according to the IEA report, it's very different in terms of the fact that it's not going to cause the harm that we would see normally our smog's causing. So it's a very different material, and again, it's much dramatically reduced in volume, and also the nature of it is very different. Now, is there any studies which show if there is much of an increase in home value because of a better BER rating? We're not involved in that side of it. I would expect it's something that is a feature. I don't know if you would come across, but in terms of home values, it's not something we'd be involved in as an organisation. But I would assume a better BER rating is becoming more and more prevalent. Does anyone, Ger or Colin, want to comment on that?
Yeah, just one thing on it. There was a time when pellet boilers or pellet stoves weren't on an SEI list, and the default, when guys were doing a BER rating, the default was an open-fired, a wood pellet, a log burning stove, which was, I think, 60% energy efficiency, which is crazy. And we had quite a battle to get pellet stoves and pellet boilers onto the SEI list and get accredited for their energy rating, energy credits recognised. Just on that, wood pellet, an oil boiler gets an energy credit rating of 5,270 kilowatt hours per year of CO2 reduction, and a biomass boiler will get 8,950 kilowatt hours, and a heat pump is 10,000. And so basically there's obligated parties that are encouraged to do energy efficiency measures and put in appliances, and they really should be encouraged to put in biomass boilers, because they can get 8,950 credits for putting in a biomass boiler with a buffer tank, compared to an oil boiler 5,200.
Yes. Okay. And then look at the 10,000. I'm assuming that it doesn't at the moment, for some reason, include the emissions coming off the electricity grid. Which is something that should be taken into account. Now, the next one, Colin, is there good data for Ireland to suggest 2 to 3 years natural drying will achieve 20% moisture content?
Is there good data? Has anybody done a study?
Sorry to cut across you on that. Our last webinar, webinar number 5, and it's online. We had 2 wood fuel suppliers on that, and 20% is very achievable in Irish conditions, but if it's done right. So if that can also be referred back to, but if any, Colin, would you have any experience, or you'd know?
It would be directly, I suppose any experience I would have would come directly from customers that are actually managing it, and there is a local log fuel supplier here in Kilkenny that supplies some of the projects that we've installed, and their moisture content on delivery after about 18 months with Sitka spruce in particular on headlands is coming in the low 20s. It's not down at 20, but that's after about 18 months. They typically deliver and guarantee that it's below 25%. And I was out with a client there recently, and I think his was a mixture between 22 and 24% in the stack that he got. but he'll obviously have that stacked over the winter in the same shed that he's using for the log boiler. So, and that 18 months is typically what they do in a rotation with sickle spruce. So, yeah, I've no hard scientific data. I don't know, has anybody...
So we would, the suppliers that we certify through the Wood Quality Assurance Scheme, there's methods of doing it that definitely it's achievable to get 20%. One of our suppliers is in the west of Ireland where they have high rainfall and are able to achieve 20% with natural air drying. So it is very doable, but there's techniques around it and you need to be doing it correctly. So, you know, whether it's through covers or whether it's through stacking high, there's different ways of doing it. So again, our last webinar would have gone into that quite a bit if the questioner would like to look at that one. It's on our website. Now, another one for Colm. Could you mention the suppliers of the Cackalophon if you installed them?
There's one company in Carlow, Eco Stoves. Sorry, is it ecofire.ie. I can maybe, I think we're going to share the slides afterwards. I can maybe include. Sorry, it's Ecofire Ireland.
Yeah, we won't. We tend not to get involved in just. We don't mention companies on.
Yeah,
on
yeah. Sorry, yeah. So anyone can contact me. I can pass on the details.
There's plenty of information on those. I've seen quite a number of those stoves at different shows, and they're very impressive, I have to say. And when you see the thermal efficiency of them, it's very interesting. Now, is there enough plumbers and installers in Ireland trained to fit biomass boilers for all the new builds, particularly social housing? Well, as I said, we have the register, which we have compiled, and we've provided the training on that. So we would go by that, and definitely what we've seen in the past is if there is demand, the people will come to provide its service. We would just, again, point out that it needs to be certified installers and people that know what they're doing. Particularly with biomass, we would advise that hand over fist. Now, Colm, do you have any case studies for small rural homes, e.g. cottage bungalows? Is there a minimum commercial scale? I suppose that's both for Ger and for Colm, really, in terms of the minimum scale that we'd look at.
No, there's no minimum size, I suppose. Yeah. Really, you know, it's to decide what technology best suits. If it's very small, it doesn't make sense to put in large buffer tank and you know, big gasification boiler. If there's potential to do something with a good log burning stove or a pellet stove like the ones Ger demonstrated there, you can start at any level effectively, and it's then down to a question of lifestyle. How much automation do you want? Do you have your own timber? Yeah, so it can start at any level and technically go to any level.
Yeah, okay. I just run down because we're running over time. I know we started a little bit late, so I just run down through the last of these here, and I might answer some of them myself if they're simple enough.
Yeah, I'd agree. I think boilers or wood boilers, wood fire can be used in any.
Jerry, you just went on mute there. It muted. There, I think. Can you hear us?
Yes, no, yeah, go ahead.
Yeah, sorry, it muted Andy there.
I missed your question, Noel, sorry.
No, you were on mute there when you were speaking.
Oh, I beg your pardon. Yeah, about the spirit of, I guess my presentation was that you know, domestic pellet boilers or wood boilers can be used in any domestic appliance, no matter how big or how small. You know, there might be a preconceived idea that they're for big rural properties. They can be for any property, even if it's down to a small pellet stove, a 5 kilowatt pellet stove.
Yeah, I just run down through. There's a whole host of things that have come in here in the last while, so I just want to, in discussion, because we are going to run a little over time on this. How can you grow your own timber? Again, this is which comes quite a bit. There's questions here in terms of the issues with planning licenses. That's something we've covered in previous ones, and I know that's been addressed. Let me see next. The costs. Look, there's a number of suppliers in terms of the cost of pellets that's available from various suppliers around the country. Again, that's something that can be got directly from those. Now, and my carbon emissions figures from biomass, is it not carbon neutral? Well, effectively, it is termed carbon neutral, but we have to account for everything. So the trucks bringing timber from the forest, the processing of wood pellets, all of that, or the process of making it into logs. We now cover everything when you're doing these calculations. So it's very important that every emission is included, and you take all of that into account, and including, if someone is buying a delivery of oil, there's a carbon emission in getting the oil from the ground in Saudi Arabia or wherever it came from to get it to your tank outside the back of your house. So that has taken into account as well. So we have to ensure that all emissions are calculated. So the figures that you do see there are generally based on, say, the electricity or the diesel used for harvesting. And as we see those becoming more carbon neutral fuels themselves, you will see it coming down to closer to zero. Under the RED II directive, the European directive, there is limits on what you can allow and what you can't allow. You must have something 80% renewable for biomass before it will be considered a renewable fuel. So typically you will find biomass is more than 90% of it carbon neutral. So it's and generally on the 95% level. So it's significant in its ability to do so. I have a series of comments here. The reduction of 95%, directly somebody is asking, is it realistic to suggest 95% CO2 reduction from biomass? And that's based on SEI's figures and also on the RED II directive, and that does take into account, the questioner is asking, does that take into account full growing life cycle? It does. All of that has been well worked out in terms of what you can allow and what you can't allow. And the sustainability of the fuel is now a critical component. And as of July next year, we will have to show full compliance with RED II directive sustainability criteria. Now, we've already looked at that in terms of the Woodfield Quality Assurance Scheme. That's not a problem in achieving it. So definitely the 95% figure, it does stack up, in particular for logs more so than pellets. Pellets can creep outside of that because there's a bit more energy in producing them. Now, in terms of the air pollution, the particulates matter. Yes, we have addressed that, and there's a question in terms of urban areas whether that could have a detrimental effect or not, or whether it would bring up the level beyond what it should be. We know for rural areas it is not a problem. We know in urban areas, if you're going to be replacing your open fire or your stove, the old type stoves, with more efficient appliances, you're going to get a dramatic reduction. Now, if you're replacing gas, it is going to be, there is more of an emission, and to be honest with you, technology is constantly being developed to reduce that more and more each year. But in terms of it being modelled, and it would be useful to see that modelled for just to see what effect it would have or could have on urban air, and does it have a detrimental effect or not. We are aware of a model done in Brisbane which you want to have a look at to see what effect it has. So in terms of, there's a question here on other health benefits in terms of if you go for a deep retrofit scheme, there is, I've seen some claims on health benefits of having deep retrofit in terms of the home itself. Yes, that we haven't considered that in what we've done here. We have considered predominantly the CO2, and on that basis, and it's towards the climate crisis that we face. As we've shown, particulates, if you're going to heat a domestic house with pellets, you will have 1.5 kilograms of particulates per year. Typically, particulates stay in the air for a matter of days. The half-life is 2 to 3 days, depending on the weather. If it's a wet day, the half-life is measured in a matter of an hour to 2 hours, because it's immediately washed out of the air. When you take a look at the CO2 emission, rather than the 1.5 kilograms of particulates, you're reducing the emission of CO2 by several tons. In one model, depending on the size of the house, between 5 to 10 tons of CO2. And the half-life for CO2 in the atmosphere, we're told to model CO2 over a 100-year plus cycle, because we do not have a way of taking CO2 out of the air. The emissions of CO2 that any of us have produced through any car journey that we've gone through in our lives are still up there. The nature takes it out at about half the rate that we produce, and it's increasing it by, the particulates, or the level of CO2 in the atmosphere is 400 ppm, 410 I think at the moment. Nature takes out about 5 to 6 parts per year. We put in about 12. So there's a huge stock of carbon in the atmosphere that will take centuries to take out. So we have to take that into account, and we can't ignore that. So in terms of pellet oven working in the summer, it depends on the scenario. Yes, you would tend not to, you have different scenarios in terms of turn down and how you would manage that, and it's more of a technical issue. You would tend not to run them for many hours. You tend to try and run them, and you tend to see the systems that are based on getting the pellet system to work at its most efficient for a period of time, and then shut down again. That's why you would have buffer tanks. You don't run it like oil or gas, which continually modulate and can literally turn on and off several times over the course of a minute. You don't do that with a solid fueled flame. You would run that at its most efficient, get it up to a good temperature, and then shut it off when it's done. But there's other questions in there which we can answer there as well. Maintenance requirements. So in terms of efficiency, to keep the efficiency high, Ger or Colin, would you like to comment on maintenance requirements?
Yeah, just briefly on that. I suppose two things. One is most advanced pellet stoves or pellet boilers have automatic cleaning now, so that does maintain the efficiency. And they all have vertical tubes in them now, so that the ash doesn't stick to the side of them. That's one thing. And I suppose we always do encourage people to encourage annually to service a boiler, especially a biomass boiler. They're a bit less forgiving than an oil or a gas boiler. You should service them every year, but you could get away without servicing it for a year or two. Biomass boiler, you must service it. And but they are very low maintenance in terms of customers. The user's interaction is very little now, just apart from removing ash pan, and the internal workings of the boilers are all automatic cleaning nowadays.
Okay. Any reports on the information on the size of the pellet market and its growth rate? Any comment on that?
I suppose the pellet market, it's a worldwide market. Sorry, am I on mute?
No, I can hear you.
Yeah, it's a worldwide market, growing very rapidly for two reasons. One is some power stations in Britain have been starting to use pellets, which I'm not 100% think is the right thing to be doing. But the pellet production in the world is growing rapidly. And in Ireland, in our own case, we've got two very good pellet mills and a third one, I believe, starting next year in the southern half of the country. So there's no shortage of pellets. It's one of the encouraging things, I suppose, in the journey I've been on with pellets in Ireland. Nobody asks me anymore, where do I get pellets, or is it possible to get them? People know you can get them. They're a worldwide commodity. They're imported all over Europe.
Okay. Any last comments before we shut off there? Ger, Colin?
Very briefly to reiterate the bigger picture potential here from a rural Ireland perspective. Installing a heat pump with the current energy infrastructure, electrical benefits the large power plants, whilst we might see that turn to more localized electricity production, using heat from biomass locally keeps the money in the local economy. So there's a win-win-win scenario there. So it's very important.
Yep. Yeah, I'd agree. And just my comment, Noel, to finish, we've lobbied hard for 4 or 5 years to get the SSRH scheme in place to support biomass, wood pellet, wood chip, commercial installations. I think we need to focus our attention now on domestic. Irish people are very pro solid fuel, wood heating. They understand it, and it should be supported. And I think it's a crying shame that there's no government incentive or encouragement from anywhere to install biomass boilers, and we need to start lobbying to fix that.
Excellent. Ger, Colin, thank you very much for your time today, and for everyone that's participated, thank you very much. It's been a very good session. Sorry we ran a little bit over time. We did have some technical issues and we managed to resolve those. So once again, our next webinar will be in 2 weeks' time, and we look forward to talking to you all then. So thank you very much, and we'll see you next time.
Thanks, Noel. Thanks, Teresa.